واحد اثنين ثلاثة.
This is Yazan Shwaihat, Energy and Power Engineering. We are going to represent an embedded system design, security embedded system. In this project, the presentation consists introduction and equipments and design and principle of operation. The following presentation demonstrates a project designed and built as a model for embedded system class at Princess Sumaya University for Technology to test our understanding ability to design an embedded using the 16F877A big microcontroller. Security is the main aim of this project. It can be used in any facility. It will be an embedded system using a 16F877A big microcontroller. It allows the user to activate the system by entering a 4-digit password through a 3-4 keypad. An ultrasonic and a motion sensor will be activated to monitor the environment of the facility. Equipment we used in this project: breadboard, microcontroller, BIC 16F877A, solenoid, ultrasonic sensor, motion sensor, LCD, 3x4 keypad, LED, transistor and resistance, and wires. The design, as we can see in this picture, this is our design: keypad and push button, ultrasonic, and the wires. And my partner will complete this presentation.
Assalamu alaikum marhaba. This is Amir Salame, Power and Energy student. In this project we're going to tell you about the design of this project. This is the keypad, here's the motion sensor, the LCD and the ultrasonic. This is the solenoid, and we have here the buzzer and the button, the LED. This is our PIC, and the most important thing is the 8 MHz oscillator. Here we have a voltage regulator to regulate 12 voltage to 5 voltage. This is our flow chart. It's the logic of the project, how the project works. The model, we used a cardboard and silicon to build this model. On this face we have a door, and in this demo we assumed that this is the only entrance for the facility. We placed a motion sensor above the door and an ultrasonic sensor on the door. Here we have the keypad, the LCD, and a push button. The breadboard has the PIC, the button, and the buzzer. Here we have the solenoid. We placed the solenoid on the door. The solenoid works on 12 volt. If it takes 12 volt, the knob will go inside the door here and it will lock the door. We placed a spring so that the knob, when the solenoid is not working, this spring pulls the knob back. This LCD screen is placed on the right side of the model to guide the user and to show any instructions given by the system. It's connected to the PIC through port B, bit 0 to bit 5. The contrast is fixed using a 10K resistance for a clear reading. This keypad is connected to the PIC through port D using a pull-down resistance. This buzzer, we connected it to port C bit 2, and it works using a PWM 5 kHz with amplitude 5 volts, 50% duty cycle, and as I said, it's connected to port C bit 2. Now this ultrasonic sensor, you only need to supply a short 10 microsecond pulse to the trigger input to start the ranging, and then the module will send out an 8 cycle burst of ultrasonic at 40 kHz and raise its echo. This motion sensor, we placed it above the door if it detects any motion in its range of view. As the documentation of this sensor should give us a 5-volt pulse if it detects any motion. But we have a problem with this sensor that it gave us only 3.2, or from the range 2.8 to 3.2 volts. We tried to make a logic converter using a BJT and it didn't work, so we tried to connect it through A to D, analog to digital converter, with a resolution 1024, and it works and everything is okay. Now how does it work? The system asks the user to enter a password through a keypad. Now, using the microcontroller and a 12-volt voltage supply connected to the solenoid and the PIC through a voltage regulator, it will activate the sensors, the ultrasonic and the motion sensor. I mentioned them before. If the motion sensor detects any motion in first level, then a first level security system will be activated, a sound and a blinking LED only for a short time. If anyone tried to cross or got too much near the door, the second security level will be activated. It will be a buzzer, a sound and a LED, and it will not be shut down until a correct password will be entered. If anyone from inside the building wishes to go outside, only he has to press a button placed near the door to reset the system. Every time a user wants to activate the system, he needs to put a new password. So every time you put a new password, and if you want to unlock the system, you put the same password. The next time you have to put a new password. It's not a fixed password. Every time you have to put a new password. And thank you, this is our project. Alhamdulillah.